Hi, today we're going to be talking about section 3.9, derivatives of exponentials and log functions. So we'll be specifically looking at derivatives of e to the x, a to the x, natural log of x, and log, which is log base e. That should just say log base maybe a or b or something like that. Log base e is natural log, so I want something other than log base e. And power rule for arbitrary real powers. So this is my favorite derivative because e to the x is just equal to e to the x. It's about the simplest derivative there is. So we think of it as far as in terms of u, or kind of like when we were doing implicit differentiation. I like this definition better, where it's doing, instead of x, it's doing u, where u could be some other function. Where the derivative of e to the u with respect to x is equal to e to the u du dx. So give this a shot. If we know that e to the x is equal, or the derivative of e to the x is e to the x, what would the derivative of e to the 2x be? Hit pause. Okay, hopefully you did e, oops, I shouldn't move that, I should get my pencil. E to the 2x, so that's derivative of the outside, leave the inside alone, the 2x is the inside, times the derivative of the inside. The derivative of the inside is 2. So that goes to 2e to the 2x. So hopefully you got that. Next we want to take a look at what is it if we take a derivative of a to the power of x. So it's no longer base e, which was really nice. It's now base a. And if you think about it, base e is the same definition. The derivative of e to the x is e to the x natural log of e. But the natural log of e is just 1. Therefore, we just say that e to the x is, the derivative of e to the x is e to the x. But the same property, a to the u is equal to a to the u times the natural log of a. And implicitly, you'd have to say du dx here. So give this a shot. What is 9 to the negative x powers derivative? Hit pause. Okay, well we know, again, derivative of the outside, so 9, leave the inside alone, to the negative x times the natural log of 9. Okay, so that's derivative of the outside, leave the inside alone, times derivative of the inside. Well, negative x, the derivative of that is just negative 1. So this equals negative 9 to the negative x ln 9. So now what is the derivative of a natural log? Well, the derivative of natural log is 1 over x, or the derivative, so the derivative of natural log with respect to x, or sorry, natural log of u with respect to x would be 1 over u du dx. So try this one. What then is the derivative of the natural log of 10 over x? Hit pause. Okay. The derivative of natural log is 1 over x. Well, this time we have 10 over x, so this would be 1 derivative of the outside, leave the inside alone. Okay, times the derivative of the inside. So let's see, 10 over x is the same thing as 10x to the negative first. So the derivative of that is equal to negative 10 over x squared. So negative 10 over x squared. Okay, 1 over 10 to the x can just be written as, if I do copy dot flip, it would just be x over 10 times negative 10 over x squared. So if I do that, those 10's cancel, that x cancels with that squared, leaving me negative 1 over x. Then finally we have the derivative of of log base a of x. So I wrote it correctly this time. So the derivative of the log base a of x is the same thing as we just did before, except it's 1 over x times the natural log of whatever the base is. So again, if we were doing this with the natural log of e, which would be the base of this log, is equal to 1. So again, just like e to the x is the same thing as a to the x, natural log is the same thing as log. It's just when you put in the e for natural log, it goes to 1. So let's see if we can use this one. What is the derivative of log base 10 of square root quantity x plus 1? Well, it's equal to 1 over x, but x, it's not just x this time, it's this whole function of square root of x plus 1. So derivative of the outside, we need to have the natural log of 10, leave the inside alone, times the derivative of the inside. Well, the derivative of the inside, if that's x to the first to the power of 1/2, then we do 1/2 times x plus 1 to the negative 1/2. Okay, so then this simplifies to 1 over 2, that's the 1/2. Okay, that power of 1/2 is the same thing as the square root in the denominator, where we've got another square root of x plus 1 in the denominator, so if we multiply those two, it should just give us x plus 1 times the natural log of 10. Okay, if you want to, you can distribute that to both of those, but I think I'm just going to leave it right like that. Okay, fast video, kind of quick moving, but this stuff, it's just another one of those. It's a new set of derivatives. We just need to practice them to get better at them. So bring any questions that you have, and I will see you tomorrow. Thanks.